wears signature leather jackets. He can bench press more than you. He's the mastermind behind self-driving cars and the AI revolution. He's cheated death, both corporate and personal, too many times to count. And he runs the 8th most valuable company in the world. Nope, he's not Elon Musk. He's Jensen Huang, the most badass CEO in semiconductor history and the founder of NVIDIA. NVIDIA is the hottest company on Wall Street right now. Its stock is up nearly 160% in 2023, a rally which put the company at a $1 trillion valuation. It's a title only 4 other American companies can claim. NVIDIA's incredible journey is packed with twists and turns that will leave you in awe. So buckle up. This is one ride you don't want to miss. Chapter 1. A Journey Begins. Jensen Huang has an extraordinary life story that begins in Taiwan. Born as Jensen Huang, his father worked as an engineer for Carrier, a prominent air conditioning company. When Jensen was merely 4 years old, his father embarked on a company training program in the vibrant city of New York. What he witnessed there left him awe-inspired and fueled his determination to grant his children the same boundless opportunities. And so, with unwavering resolve, he made the life-altering decision to uproot the family and head for the United States. At the age of 9, after a few years in Thailand, Jensen's parents made the decision to send him and his older brother to America. They found a boarding school called Oneida Baptist Institute in eastern Kentucky, a place that was affordable for the family's limited finances. However, unbeknownst to them, this wasn't your typical preparatory school. Instead, it was a reform institution for troubled youth. Jensen's arrival at Oneida Baptist Institute marked a stark contrast to his prior experiences. Suddenly, he was thrust into an environment that tested his mettle, sharing a room with a 17-year-old who had recently emerged from prison, bearing the scars of a knife fight. As one of the few foreigners and Chinese individuals in the town of Oneida, Jensen confronted cultural disparities head-on and had to adapt swiftly to his unfamiliar surroundings. Chapter 2. The Pursuit of Excellence. Despite the difficulties and unconventional circumstances, Jensen persevered and embraced his new surroundings. Despite the age difference and diverse backgrounds, Jensen befriends a kid named David, who helps him with math and introduces him to weightlifting. Jensen develops a passion for weightlifting and becomes remarkably muscular over the years. After moving to the US, Jensen's parents emphasize academic discipline and his intellect becomes evident. He skips 2 grades and enrolls in college at the young age of 16 at Oregon State University. His love for mathematics leads him to pursue a major in electrical engineering. Jensen excels in his studies, becoming one of the top students in the school. Jensen's passion for precision and attention to detail becomes evident during his time at university. He becomes frustrated with professors who fail to use precise numbers in their discussions, highlighting his commitment to accuracy. Not only does Jensen fall in love with electrical engineering, but he also falls in love with his lab partner, Laurie. They both graduate from college, with Jensen completing his degree in 1984 and Laurie in 1985. The couple moves to Silicon Valley, where Jensen begins his career at AMD, Advanced Micro Devices, as a chip design project manager. Jensen's role revolves around the development of a 1 MHz CPU chip, a blazingly fast marvel for its time. Jensen's passion for precision, coupled with his love for electrical engineering and the support of his partner Laurie, becomes the bedrock of his journey as he steps into the world of technology and entrepreneurship. Chapter 3. The Birth of NVIDIA. While working at AMD, Jensen pursues a master's degree in electrical engineering at Stanford University. He spends 8 years juggling his work at AMD and later at LSI Logic with his studies. Just before the inception of NVIDIA, Jensen successfully completes his master's degree, marking a significant milestone in his educational journey. Jensen Huang was working at LSI Logic, a premier ASICs, application-specific integrated circuit company that made custom-designed chips for other companies. Jensen's friends and fellow engineers Chris Machowski and Curtis Priem approached him with an idea to start a company focused on creating a graphics card for PCs to enable 3D graphics. This was during a time where there was a growing demand for 3D graphics, especially in the gaming industry. Recognizing the challenges involved in chip design, he realizes that only a few companies, such as Intel and AMD, possess the capability to design chips effectively. Jensen recognizes the lack of dedicated chip manufacturing companies and the manual nature of chip design processes at that time. Jensen's epiphany became the catalyst for his remarkable journey and the birth of a company that would change the game forever. Despite the uncertainties and risks associated with the idea, Jensen, Chris, and Curtis decided to pursue it. With a mere $40,000 pooled together, the three co-founders set out to reshape the technological landscape. Jensen informed Wilf Corrigan, the CEO of LSI Logic, about their plan and his intention to resign. Wilf, having a background in the semiconductor industry, questioned the viability of the market and the existence of a developer ecosystem for PC gaming. Nevertheless, he referred Jensen to Don Valentine, a renowned venture capitalist and the founder of Sequoia Capital. Jensen went to meet with Don Valentine, but he nervously stumbled through his pitch, leaving Don skeptical. However, based on Wilf Corrigan's recommendation, Don decided to invest in the venture. Sutter Hill Ventures also joined the round, resulting in a $2 million investment at a $6 million post-money valuation. At this point, the company needed a name. They settled on NVIDIA, by combining the Latin word NVIDIA, meaning envy, with the abbreviation NV from their working files for the next version, .NV. And in 1993, NVIDIA was born. The name hinted at their ambition to be the envy of the industry. At that time, the company ventured into the highly competitive and low-margin market of computer graphics chips. With 90 undifferentiated competitors, NVIDIA faced significant challenges. Despite the initial enthusiasm for the idea, many other companies were also funded around the same time to pursue similar goals. This added to the competitive landscape and the challenges NVIDIA would face as it embarks on its journey to establish itself as a leading player in the graphics card industry. Chapter 4: Trailblazing Innovation. NVIDIA's breakthrough came in the form of graphics processing units, GPUs, which became crucial components for desktop and laptop computers. Through relentless innovation and the ability to deliver superior products, NVIDIA captured an impressive 83% market share in standalone GPUs. But NVIDIA's success didn't stop there. Under Jensen's leadership, the company explored new frontiers, pioneering hardware and software development tools for machine learning, neural networks, and deep learning. This move positioned NVIDIA at the forefront of the cloud and data center industry, shaping the future of computing in the process. Once again, faced with a critical turning point in NVIDIA's history, Jensen Huang found himself grappling with an unprecedented challenge. NVIDIA had invested significant time and resources into developing the NV2 chip, anticipating that Sega would adopt it for their upcoming game console, the Dreamcast. However, Sega's unexpected decision to switch directions left NVIDIA in a precarious position. NVIDIA's NV2 chip was meticulously designed to be highly efficient with memory usage, but relied on costlier components compared to its competitors. The rapidly dropping prices of memory chips due to Moore's Law presented a significant obstacle for NVIDIA's future success. Moore's Law is a principle named after Gordon Moore, one of the co-founders of the Intel Corporation. In simple words, it suggests that the processing power of computers tends to double every couple of years, while the cost per unit decreases. This observation has held true for several decades, driving advancements in technology and enabling the development of smaller, faster, and more powerful electronic devices. The company found itself at a crossroads, with only 9 months of financial runway remaining. For most companies, this dire situation would be the signal to pull the plug, but Jensen Huang wasn't ready to surrender. Embodying the spirit of intellectual honesty that he had fostered within NVIDIA's culture, Jensen gathered his co-founders Curtis and Chris, both engineers, to confront the harsh reality of their predicament. They had amassed a talented team of over 100 engineers, all lured by NVIDIA's ambitious technological vision. However, it became clear that their current path was no longer feasible. Jensen presented an audacious plan to save the company. Acknowledging that their initial approach of developing proprietary technology was unsustainable, Jensen proposed a radical shift in strategy. NVIDIA would standardize on the same Microsoft Direct 3D as their competitors, aligning with the established industry standards. While this might not have been an inspiring vision for Silicon Valley engineers seeking to pioneer groundbreaking technologies, it was a pragmatic and necessary step to ensure survival. The decision to pivot towards competing solely on performance while utilizing standardized architecture required NVIDIA to out-engineer their rivals consistently. Jensen's message to his team was clear. They had to be smarter, more efficient, and faster at engineering decisions, all while delivering superior performance at a lower price point. Jensen recognized the importance of timing. Microsoft's dominant position in the market meant that most developers were already aligned with their AIPs and tools. NVIDIA had to compete head-to-head with other graphics card manufacturers on the basis of raw engineering ability. They needed to prove that they could constantly outpace their competitors, not just in design, but also in shipping the next generation of chips promptly. Chapter 5: A pivotal moment. Can you imagine a world where graphics cards were just like any other product? A world where every manufacturer offered the same basic functionality, leaving little room for innovation? Well, that's exactly how the graphics card market had become commoditized. All manufacturers essentially provided the same functionality, offloading 3D graphics processing from the CPU onto a dedicated chip. The differentiation lay in the price-performance ratio and the ability to keep up with Moore's law, pushing the boundaries of what integrated circuit manufacturing techniques enabled. With only 9 months left before their financial resources depleted, NVIDIA faced an arduous task. Jensen and his team made the difficult decision to downsize the company by laying off 70% of its workforce, reducing the team to a lean and focused group of 35 individuals. They embarked on an extraordinary endeavor to design and ship a new chip within this incredibly tight time frame, a feat that typically required 2 years under normal circumstances. To overcome this challenge, NVIDIA turned to cutting-edge emulation technology. Investing a significant portion of their remaining funds, they acquired hardware and software that allowed them to simulate the graphics chip they were designing. It was a brilliant move, saving them precious time. However, it came at a cost. The emulator ran at a painfully slow pace, churning out just 1 frame every 30 seconds. The debugging process became a grueling task, with someone painstakingly observing each frame to ensure the output matched their expectations. Driven by sheer determination, NVIDIA managed to complete the design phase in just a few months. Armed with their meticulously crafted design, Jensen Huang and his team took a daring leap of faith. They contacted their chosen foundry, one of the secondary options available to them, and boldly instructed them to proceed with the tape-out, the finalization of the chip design for production. The foundry, understandably taken aback by NVIDIA's decision to forego physical prototypes, questioned their choice. However, Jensen and his team remained resolute, affirming their confidence in the design. Despite the risks associated with relying solely on emulation and without the luxury of rigorous prototype testing, they placed an order for the production of 100,000 units. It was an all-or-nothing gamble that had to pay off if they were to avoid financial collapse. The months leading up to the chip's release were marked by intense pressure, long hours, and sleepless nights for the remaining NVIDIA team members. They tirelessly refined and optimized their design, continuously pushing the boundaries of what was possible within the constraints of the industry and Moore's law. Finally, the day of reckoning arrived. NVIDIA's new chip, forged through unwavering determination and resourcefulness, was ready for the world. They had managed to achieve what seemed impossible, an accelerated chip design cycle of a few months instead of the typical 2 years. As the first units of their new graphics chip hit the market, the industry held its breath, waiting to see if NVIDIA's audacious move would pay off. To the astonishment of many, NVIDIA's chip emerged as a resounding success. It showcased remarkable performance, rivaling and even surpassing that of their competitors. Despite the challenges faced during its development, the chip proved to be a game-changer, solidifying NVIDIA's position as a formidable player in the graphics card industry. The story of NVIDIA's survival in the face of adversity serves as a testament to the resilience and ingenuity of its founder and his team. Jensen Huang's audacious decision to pivot, embrace industry standards, and out-engineer the competition showcased his visionary leadership and unwavering commitment to NVIDIA's mission. It became a pivotal moment in the company's history, ultimately laying the foundation for its subsequent dominance in the graphics card market. Chapter 6: Future Success and Challenges. NVIDIA's ability to ship new hardware generations every 6 months becomes a significant advantage for them, as they can deliver double the performance of previous generations in a shorter time frame. They start gaining substantial market share and attracting attention from industry players. In 1999, NVIDIA rebrands its product and introduces the GeForce line, which becomes highly regarded in the gaming ecosystem. The GeForce 256, marketed as the first GPU, offers 5 times better graphics performance than its competitors. This technological marvel astounds the world. It's a game changer, a significant milestone for NVIDIA, propelling them to the forefront of the graphics card market as undisputed leaders. By 2000, NVIDIA had secured an exclusive role as the graphics provider for Microsoft's groundbreaking Xbox console.
Microsoft and the Xbox happened at exactly the time that we invented this thing called a programmable shader, and it defines how computer graphics is done today.
In 1999, NVIDIA went public, but its stock remained fairly stable. As time pressed on, NVIDIA's unwavering commitment to excellence presented them with yet another remarkable opportunity. Enter Sony, the arch-nemesis of Microsoft, seeking NVIDIA's brilliance to power the graphics hardware of their prized creation, the PlayStation 3. Fueled by their arsenal of technological breakthroughs, NVIDIA seamlessly infused their advancements into the very core of the PS3, cementing their position as trailblazers in the gaming realm. Then, in 2006, NVIDIA unleashed a game-changing software toolkit called CUDA, sending shockwaves through the industry. This transformative platform and programming model reshaped the workings of NVIDIA GPUs, shifting them from sequential to parallel computing. This pivotal innovation propelled NVIDIA to the forefront of the AI revolution, firmly establishing their position at the center of a burgeoning technological boom.
Parallel computing is, let me take a task and attack it all at the same time using much smaller machines. Right? So it's the difference between having an army where you have one giant soldier who's able to do things very well, but one at a time, versus an army of thousands of soldiers who are able to take that problem, right, and do it in parallel. So it's a very different computing approach.
Over a decade ago, NVIDIA's CUDA and GPUs played a pivotal role in an event that would reverberate across the world of artificial intelligence. It all began with AlexNet, a groundbreaking neural network that marked the Big Bang moment for AI. This revolutionary network shattered the competition during a prestigious image recognition contest in 2012, showcasing unprecedented accuracy. What's fascinating is that the very same parallel processing that propelled NVIDIA's GPUs to create breathtaking graphics proved to be the perfect fit for deep learning. In this realm, computers learn independently, free from the constraints of traditional programming code. It was a game changer.
You had the good wisdom to go put the whole company behind it. We saw early on, about a decade or so ago, that this way of doing software could change everything. And we changed the company from the bottom all the way to the top and sideways. Every chip that we made was focused on artificial intelligence.
Back then, Brian Cantazzaro stood as the lone warrior, the sole member of NVIDIA's deep learning team. 6 years have passed and the team has blossomed into a force of 50 talented individuals with no signs of slowing down.
For 10 years, Wall Street asked NVIDIA, why are you making this investment? No one's using it. And they valued it at $0 in our market cap. And it wasn't until around 2016 that after, 10 years after CUDA came out, that all of a sudden people understood this is a dramatically different way of writing computer programs, and it has transformational speedups that then yield breakthrough results in artificial intelligence.
Today, tech giants like Microsoft and Google rely on thousands of NVIDIA A100s to power their data centers. These impressive machines are the driving force behind training large language models like ChatGPT.
When we ship them, we don't ship them in packs of 1, we ship them in packs of 8.
With a hefty price tag of nearly $200,000, NVIDIA's DGX A100 server board houses 8-ampere GPUs that work together to enable ChatGPT's lightning-fast and remarkably human-like responses.
I have been trained on a massive dataset of text, which allows me to understand and generate text on a wide range of topics.
In the race to excel in generative AI, companies proudly boast the number of NVIDIA A100s they possess. Microsoft, for example, trained ChatGPT with a whopping 10,000 of these powerful machines.
It's very easy to use their products and add more computing capacity. And once you add that computing capacity is basically the currency of the valley right now.
While AI and ChatGPT have been generating a lot of buzz for NVIDIA, it's far from Huang's only focus.
And we take that model and we put it into this computer, and that's a self-driving car. And we take that computer and we put it into here, and that's a little robot computer.
Like the kind that's used at Amazon.
That's right.
Companies like Amazon rely on NVIDIA to power robots in their warehouses and create digital twins of massive spaces. These simulations help optimize the flow of millions of packages each day. Surprisingly, the same Tegra chips that didn't fare well in mobile phones now drive these robotic units. They play a vital role in the world's largest e-commerce operations. NVIDIA's Tegra chips have also made their mark in the automotive industry. They were used in Tesla's Model 3 vehicles from 2016 to 2019. Although Tesla now uses its own chips, NVIDIA continues to develop autonomous driving technology for other car makers like Mercedes-Benz.
So we call it NVIDIA Drive, and basically NVIDIA Drive's a scalable platform, whether you want to use it for simple ADAS, assisted driving, for your emergency braking warning, pre-collision warning, or just keeping, holding the lane for cruise control, all the way up to a robotaxi where it is doing everything, driving anywhere, in any condition, any type of weather.
What do you say to gamers who wish you had kept focus entirely on the core business of gaming?
Well, if not for all of our work in physics simulation, if not for all of our research in artificial intelligence, what we did recently with GeForce RTX would not have been possible.
When it comes to graphics, NVIDIA is always pushing the limits. In 2018, they released RTX, a technology called ray tracing that's used in almost 300 games.
For us to take computer graphics and video games to the next level, we had to reinvent and disrupt ourselves, basically simulating the pathways of light and simulate everything with generative AI. And so we compute one pixel and we imagine with AI the other 7. It's really quite amazing. Imagine a jigsaw puzzle and we gave you 1 out of 8 pieces, and somehow the AI filled in the rest.
You'll find it in popular titles like Cyberpunk 2077, Fortnite, and Minecraft. But that's not all. NVIDIA's GeForce GPUs in the cloud let you stream over 1,500 games at the best quality to almost any PC. It's like having a vast library of games at your fingertips. But NVIDIA doesn't stop at gaming. Their technology also makes simulations possible, like predicting how things behave in the real world. It's useful for climate forecasting and developing self-driving cars that have been virtually tested for millions of miles. NVIDIA calls this whole concept the Omniverse, and it's their next big focus.
We have 700 plus customers who are trying it now, from the car industry to logistics warehouse to wind turbine plants. And so I'm really excited about the progress there. It represents probably the single greatest container of all of NVIDIA's technology: computer graphics, artificial intelligence, robotics, and physics simulation, all into one. I have great hopes for it.
NVIDIA's journey is a testament to their unwavering commitment, innovation, and ability to adapt. They have transformed the industry, pushing the limits of what's possible, becoming a force to be reckoned with. Jensen Huang's success story serves as an inspiration, reminding us that true trailblazers never shy away from challenges, but instead embrace them whole. It's a story of determination, innovation, and a little bit of madness. But hey, that's what it takes to change the world, right? NVIDIA's incredible journey is just one of the many epic startup stories we've covered. If you're hungry for more tales of disruption and innovation, you have to see this next video on how Uber turned the taxi industry on its head. Make sure to hit that play button and I'll see you there. Cheers.